So we take a look at this problem. This one is we're getting a little bit more complicated with each one of these. 3.2 times 10 to the negative fourth moles of sodium hydroxide is dissolved in 2.9 liters of water. What's the pH and what's the pOH? So as with a lot of these kinds of things, when I first read it, I want to assess what's going on in this situation. So we've got some number of moles dissolved in water. This stuff is sodium hydroxide. They want to know the pH and the pOH. So one of the first things I want to identify is, what kind of stuff is this? Well, sodium hydroxide is a base, right? I shouldn't pause on the A, because then you know it's got to be base because of the whole and a thing, right? Whatever. So it's a base. So once I know the concentration, when I do the negative log of that, that's going to give me the pOH, right? Since it's a base, what I would measure directly is the pOH. Again, the pH scale is more common, but in this case, what I would find would be the pOH, and I could translate that to pH. As a good rule, like, okay, well, this is a base thing, so it should have a low pOH, and it should have a high pH. I'm just saying like above 7, below 7 kind of thing, right? It's always nice to orient yourself for these kinds of things, right? The math is less important than this particular math, right? Than understanding what it is that we're looking at overall. So job number 1 is to figure out, I need to get negative log of the OH minus concentration. So negative log, well, concentration, remember, was moles divided by liters. So I'll do negative log of 3.2 times 10 to the negative fourth divided by 2.9. Instead of doing that in 2 separate problems, I'm just writing it all at once, right? So let me use the calculators we have up here at school. Again, cell phones just don't make very good calculators. I don't actually love these calculators. I like the cheap little Texas Instruments ones that are like $10. They're pretty common outside of this school. We like these, but I tend to think students have more trouble with them. But in any event, I'm going to do 3.2. Well, hang on, parentheses, 3.2 times 10 to the, right? Remember the old, when we were doing scientific notation stuff, times 10 to the button, negative 4. So I put that into the calculator, 3.2 times 10 to the negative 4, divided by 2.9. And so that gives me my concentration. So my concentration is pretty low. Again, logs are about powers of 10. So this looks like it's 1, 2, 3, 4 powers of 10. So I'm expecting a pOH of in the neighborhood of 4, right? So negative log of my answer. Again, if you don't use calculators a lot, there's some things you can do to make your life easy, right? Second and the negative thing there is your answer. So you don't have to retype those numbers in. And that's going to give me a pOH of 3.95, which again was right in that neighborhood of 4, which was how many decimal points we were going to have to move it, right? I keep holding that up like I was doing that, right? If you've got a different kind of calculator, right, like one, again, not like everybody has to have a graphing calculator, but if I do that same thing, I could do it all at once. Negative log of, and then in parentheses, 3.2 times 10 to the negative fourth divided by 2.9. If you have an EE button like this, if you have an EE button, it will automatically bind all the stuff together, so you don't have to do the parentheses around the scientific notation stuff. So negative log of 3.2 times 10 to the negative fourth divided by 2.9, and that gives me, again, 3.95, right? The same thing there, the 3.95. I don't know how well you can see that. 3.957, so I guess 3.96 if I'm rounding more carefully. That is a low pOH, sorry. That's a low pOH. That's what I was expecting. So for my pH, I would just do 14 minus 3.96. I should go ahead and correct that since I noticed I hadn't bothered to round. So 14 minus that answer, and that gives me a pH of 10.0, which is on the basic side, right? That makes sense. You can get outside the range of 0 to 14. It is possible. It just means you're dealing with things bigger than 1 molar, right? And so by then you just normally look at concentration. You don't normally bother with pH. But if I have a 10 molar acid, that's possible. It would just have a pH of -1 kind of thing, right? Anyway, as we do more complicated ones, hopefully these are making sense.